So should I get started?
Yep, good.
Okay. So let me introduce myself. My name is Andy Grigorowitz. I work for the Mitre Corporation, which is a nonprofit organization that manages a collection of federally funded research and development centers. And some of the work that we've done through our Center or our CMS Alliance for the Modernization of Healthcare, Federally Funded Research and Development Center, or essentially the organization that works with ONC, is we've essentially produced a set of open source tools that I'm here to talk about, and hoping that folks that are participating in the Code-a-thon would be able to leverage going forward. So one of the things that we have done is, in the past, Mitre and ONC worked together to create an open source platform called Pop Health. And Pop Health focused on the calculation of electronic clinical quality measures. Now, electronic clinical quality measures, for those of you who may not be familiar with them, they are different tests that can be applied to patient information to see if they are getting the standard of care that they should. A simple example of that would be you can look through somebody's medical record to see if they have had their flu shot for the year. And if they have been into a given provider's office during the course of the year, during the right season, were they given a flu shot? And if they weren't, then you can take actions to get them their flu shot and hopefully provide them with better care. That is obviously a simplistic example, but there are much more sophisticated examples if you think about the immunization regimen that children typically undergo as they're growing up. They have a number of shots that have to be provided at just the right time for all those immunizations to have the appropriate effect. And so keeping on top of that we can do that with software, but it can be a challenge. And so when you're calculating these electronic clinical quality measures, they're only as good as the data that they're given. So if you are seeing multiple providers, you could wind up having that data being fragmented. And so what we have seen is that providing data to electronic clinical quality measures to engines that are trying to calculate these sorts of things, it can be a challenge. We've seen that patient data can be collected via different streams. So you could have data coming in from clinician systems, like their electronic health record systems, or you could have claim streams coming in as well. So for health information exchanges, they often see this problem. And then also you can have duplicate records that exist for a single individual. And as you can imagine, if you visit multiple healthcare providers, you may have different records at those different provider systems. And so figuring out who the single individual is so that you can bring all their data together in one place, that can be a bit of a challenge. So what ONC asked Mitre to work on was enhancing the Pop Health system to address these issues. Oops, let me try this. Okay. Now, what we could have done is we could have put together some software to really bolt on to Pop Health and try to address some of the issues that ONC was raising. But instead, what we decided to do is step back and take a look at the overall architecture of the system and what we were trying to achieve with ONC. And we arrived at a very different architecture. And what I'm showing here is an overall idea of the components that we have available and how they all work together to form a system. And what I'm going to do is walk you through each of these components with a little bit of a demonstration. Well, not through each of them, but I'll walk through some of them with a bit of a demonstration. And hopefully you can see how these could potentially be leveraged in software that you would want to build. At the core of our open platform that we have here is a Fire server. And we have really focused on the use of Fire for the storage of healthcare information. That fire server is protected using the HART specification, and particularly through the use of OAuth and OpenID Connect for authentication and authorization. And with that authentication and authorization layer, we have different services that can access that fire server to provide additional value. We have the calculation of electronic clinical quality measures. We have patient matching so that we can try to identify the same patients in a data set. Patient merging so that once we have identified the same patients, we can try to collect their information down into a single record. Record completeness, which I'll talk about, that gets into another aspect of improving data quality, and a claims importer, but we're not going to delve too deeply into that into this presentation. I'll pause for a second if there are any questions. Okay. So first, let me talk about our fire server. We have an open source fire server that is available at the URL that you see there. It's on GitHub. It currently supports versions DSTU2 of the fire specification, as well as Fire DSTU3. So that is available to you. It sort of operates like a library, so you can kind of embed it into other systems that you're building, or you can run it as a standalone server. If you go to that site, you will be able to see you can see how that works in action, and you can download the code to build your own executable. Another effort that, so to give you an idea of what our fire server looks like in action, I'm just going to quickly switch over here to the web browser, and this will give you an idea of what things look like. But we built a very quick and dirty user interface for looking at patients that we generate. So we also have a patient generation tool called Cynthia, which I used to generate all the data that you see here in this web user interface that I have. And if we click through, we can see I actually have a set of duplicate records. I've intentionally duplicated some records. We'll talk a little bit more about that as we get further into the presentation. But you can see that I've actually duplicated some records here, and we have different bits of information about the patient that we're looking at, and we can drill down and see different medications or observations that are associated with our particular patient. So this is just a very brief demonstration of the fire server that we've created, and it supports all the fire resources. So if you wanted to use that as a tool to point to store your information in, that is available to you as open source software. Okay, so we have this fire server. The fire server, if you start to work with it, it does offer different levels of security for authorization and authentication. So it really operates in three separate modes. You can run our fire server completely open so that it would be unauthenticated. Any requests that go to it would just be able to do whatever they wanted to do. You would be able to see all information. The second mode that you can run it in is what I refer to as plain OAuth and OpenID Connect mode. So it's really unprofiled OpenID Connect and OAuth 2.0. So our server can act as an OAuth 2.0 resource server, as well as an OpenID Connect relying party. So if you were to connect this, if you were to connect our fire server or pair it up with something like Mitre ID Connect or any other OpenID Connect identity provider, it will be able to work with that identity provider to have users authenticate at that identity provider, and then obtain that authentication information from the identity provider. And then it will also be able to delegate authorization through that identity provider, which would act as an OAuth 2.0 authorization server down to the fire server. Our fire server, when you're delegating permission, it also supports the scopes, the OAuth 2.0 scopes that are defined by the Argonaut project. as well as the SMART project and HEART, they all sort of define the same pattern for scopes. So we support things like read and write scopes against particular fire resources. So for instance, you could grant a particular client access to only conditions and observations and the patient resource, but maybe not medications. That's up to you, but the fire server that we have available as open source provides all that functionality. Lastly, it can be put into a HEART compliant mode where it will still operate as an OpenID Connect relying party and OAuth 2.0 resource server, but it will support the full HEART profile where it provides you that advanced level of assurance. You will need to generate your own public-private key pair for the server, but once you do that and share that with the identity provider that you're working with, it will be able to do things like sign the request that it sends back to the server so that you can be assured that nothing's being tampered with in the middle. So all of that technology is currently baked right into our fire server and available for you to use. Any questions at this point? Okay. So the next thing that I want to talk about that can be leveraged within our platform. Oh, do we have a question here? Let me just see. Oh, okay. Sorry. So the next part of the platform that I want to talk about is our electronic clinical quality measure, or ECQM component. So with our electronic clinical quality measure component, we actually have made available open source software that is able to calculate the stage 2 electronic clinical quality measures. We offer services through a RESTful API. So this RESTful API will actually, it provides you an interface that you could build whatever client you wanted to, but this is a piece of server software that will then go back and contact our fire server. Working with our fire server, it will do things like calculate the electronic clinical quality measures for a given patient just by reading their clinical information out of a fire server. We also provide a web-based user interface. Again, this is all open source software at the GitHub URLs that you see here, where you can go and then and you could direct users to that web-based interface, which is sort of a fully packaged solution to show them the clinical quality measures in action. So I'll just give you a brief demonstration of that. So you notice we had this patient here, Cara Denisig. What we can do is go back here and look at our electronic clinical quality measure service. And what I'm going to do is select a particular measure. The one I'm going to look at is for the documentation of current medications in the medical record. So what this electronic clinical quality measure is doing is it's saying anytime that a patient has an encounter, so basically anytime that they go to the doctor, are the providers doing documentation of their current medications? So are they asking them if the medication list that they have on file is correct and accurate with regard to the medications that patient is taking? And so this is just a web-based interface that lets you kick off jobs to run against the fire server to calculate these clinical quality measures. And it will display the results. So you can see out of our 168 patients, they have a number of encounters. These are the encounters that qualified for this particular clinical quality measure. We can drill down in and we can see our Cara Denisig patient there. We have a pointer directly back to her fire record. And we can see, fortunately for Cara, she's actually in the numerator for this measure, but it will, this software, if you're using it either through our user interface or through our set of RESTful services, it has the ability to provide you numerator information. So these are the people that are receiving the standard of care. Denominator information. So these are everyone that qualifies for the measure. And then maybe even most importantly, these are the outlier patients. So these are patients that had an encounter where their medication, their current medications were not documented. So this would be a potential place for someone to build an application where they could then contact the patient and have a provider work with them to make sure that their medication list is up to date after the fact, so that you can be certain of the medications that a given patient is taking. All right. So that is our eCQM set of services. Next, we have patient matching. And when we talk about patient matching, essentially what we have tried to do here, both Mitre and ONC, is one of the things that we noticed is that there are a number of patient matching vendors on the market right now, both open source and commercial systems or closed source systems for looking at your patient registry, your master patient index, and trying to clean that up, trying to determine what the duplicate records are in your particular healthcare enterprise. Now, those systems are great, but one thing that we noticed about those systems is that they often require a level of proprietary integration to a healthcare enterprise. So if you wanted to bring, if you found a particular software package that performs patient matching and you wanted to bring that onto your network, you typically have to do some level of custom integration to get that solution working with your data and starting to return matches to you. Now, we were not happy with that situation for a number of reasons. It makes it difficult for organizations to compare the effectiveness of different patient matching systems, because every time you brought in a different matching system, there's some level of custom integration that you needed to do. So the more comparisons that you wanted to perform, the more expensive it became because of all the integration work that you needed to do. Secondly, assuming that you've chosen a system, you somehow find a system that you're happy with. Now that you've done this custom integration work, there's a lock-in factor there, where if you wanted to replace that system in the future, again, you would have to go through the pain of a custom integration to bring that system on, to bring a replacement system onto your network and starting to work with your data and identify matches. So what we worked on is creating a specification for how patient matching systems could work with using FHIR just through a standards-based interface. So if you have a particular matching algorithm, that you would be able to integrate that in one standard way, and then using that one standard way, you could, in theory, start to swap in and out matching systems, so that you didn't have to do that custom integration every time you wanted to bring a new matching system online. So at the URL that I have below here, that is where we have our specification for patient matching systems, so how they work with FHIR. And we actually use FHIR, so we have a patient matching test harness, which I'll talk about on my next slide, that actually has a way of queuing up jobs for record matching systems, so that we could say, hey, we would like you to match all the patients in Massachusetts, and then that job would make it back to the record matching system through FHIR, and then the record matching system would use FHIR to obtain all the different patient records and do its matching logic. And then lastly, it would be able to take the results of its matching and write those back to the FHIR server, where we would be able to use those. So all of that information is actually how all that flow works is provided at the URL below in our test harness interface specification. So what we were able to do is we have more open source software that you can see is available to you here. So we have our patient matching test harness. What that allows you to do is it's a set of RESTful services. So again, you can use just a RESTful backend if you wanted to build your own user interface on top of it. But we have a set of RESTful services that you can use to indicate that there are different matching systems as a part of your enterprise. You can create matching jobs, which then go into our FHIR server. And then as the different record matching systems come online, they can pick up those jobs, perform those jobs, so perform those matching tasks. And then when they're done with those matching tasks, they can write the results back into our FHIR server, which we then have the capability to display and compare. What you can see a screenshot of below is our patient matching test harness, and I'll actually give a demonstration of this in a moment here. But this is our user interface. Again, we have another web-based user interface that can be used to explore the different things that I just mentioned. So I'm going to go back here to my home page and drill into the patient matching test harness. So you can see here that I have a data set. Well, I have a data set in here that I generated from Cynthia, which I described. This is the same demonstration that I just gave at the HIMSS conference. And so I tagged my data set in here with HIMSS, but we can actually tell patient matching systems about different record sets that we would want. So essentially, if you can describe it via a FHIR query, we can hand that off as a patient matching system as a match job. So in here we're saying match against, find duplicates in any patients in our FHIR server that are tagged with HIMSS. But you could do, find me any duplicates for female patients in Virginia or something like that. And that would be a valid record set that you could hand off to record matching systems. What I'll show you next is we've created a different challenge between two different patient matching systems, an open source matching system called Frill, and then just some custom built software that I have over here on the right-hand side. You'll see we're currently calculating 3 different metrics for our patient matching systems. Recall, which is essentially the thoroughness of the matching system. So out of the total number of duplicates in our data set, how many did the matching system find? We have precision, which is given the matches that you've returned to us, how many of them are correct versus how many are false positives. And then finally, we have F-score, which is it's a harmonic mean or a combination of both recall and precision. But you can see here quickly at a glance, through our web interface, we give you the ability to compare different systems. And you can click on one of these and it will actually drill into the individual systems. We're tracking different runs that we've performed over time here. So I can tweak parameters in my matching algorithm and then tell it to run again, and you'll see how it performs over time. And then we can even drill into the individual matches that we have. So this will return, and this is, to a certain degree, we're working with toy data. So if you had more interesting data, the results will look more interesting. But we show the top 5 matches and bottom 5 matches by confidence score, although they're all the same here for these. And we even provide links back to the individual FHIR records. So if you wanted to go all the way back, you can see here, this is the JSON for that particular record, which isn't terribly interesting. But you can go all the way back and look at the individual FHIR records that the matching system returned. So that's a brief summary of our matching services. Let me pause briefly to see if there are any questions. Okay. The last things that I want to talk about here are patient merging and record completeness. So record completeness and merging, what we are working on right now is we have a FHIR scorecard application, which you can see at the URL that I have below. And what that what that FHIR scorecard service does is it will look at an individual FHIR record, and based on that FHIR record, it will give you a score as to the quality of that record. So it will try to show you, or it will inspect if that record has medications, if it has conditions, different pieces of information like that that you would expect to find in a full and complete electronic health record. It will also look at not even necessarily the presence of a condition, but the fact, is that condition coded? If it's coded, is it coded in a code set that you would expect for a condition? So does it, if it were a condition, is it coded with an ICD-10 code or a SNOMED code? So it will look for information like that. And actually, I can jump over to a demonstration of that as well, where you can see if we, if I go back here to my patient list and I select one of my patients, you can see here I can actually ask for the FHIR scorecard. Oh, you know what? I realized that I am not running my FHIR scorecard service, so apologies for that right now. But we do have a scorecard application. I shouldn't have taunted the demo gods like that. But you can obtain the software here. And we have a record merging service. I don't have the URL in the presentation, but I can certainly make it available. We do have software available that you can provide a pointer to two different fire records to this piece of software. Given that you have these two fire records, it will attempt to merge them automatically. So if it finds two conditions that are identical, it will assume that they are the same and move forward with that. If it finds any sort of conflict, like information exists in one record or not the other, or that say a medication has a different dosage in the different medications, it provides a user interface for you to walk through to select either the left-hand side or the right-hand side, or neither. You can actually discard information if you feel like it's not worth bringing into a new record, but it allows you to move forward and unify those records together. So those are the different open source services that we have provided, and I hope that folks that are participating in the Code-a-thon find them helpful and find them useful. And if there are any questions, please feel free to ask.